Okay, so let's continue from where we left off during the lesson in class. And the last thing that we were doing was to go through and to calculate the average temperature for each month in the year 2010. And to do this, we did get through this part of the lesson in class, but just to kind of remind you, we first made this variable means 2010, which was set equal to np.zeros with a size of 12, essentially just an empty NumPy array with 12 months, so we have one spot for each month to put in the average monthly temperature for that month. We also had this variable index equals 0, and I'm actually going to cut this and put it down here above the for loop in the cell beneath it, and the reason for that I'll talk about in just a second. But anyway, we can run the first cell just to make our empty array of zeros for the 12 months. And then down here we have a for loop, and with the for loop we have this variable index that gets set equal to 0 first, and you can see that each time through the for loop it's going to get one bigger than it was the previous time through. The reason for moving this index down into the same cell as the for loop itself is the fact that if I had it in the other cell and you run this loop 2 times in a row, there's nothing that resets the index value to being equal to 0. So you'll have some issues that you will have index values that are outside of the range of values in the means array, for instance, the second time you run this. And you might get an error message that's not that obvious. Anyway, the point of what was going on here with the for loop is we were going to go through each month, and for that month we were going to take the values out of Tmax, the maximum temperature that we had already cleaned for NaN values, so no nans are in there. And then for the month that's equal to month now, so the month now variable is the list, it's the variable here for the month in the for loop. So the first time through it's going to be 0, 1. Remember, this is a string, character string. And so it'll be the month of January. And we are going to take all the values out of Tmax for the month of January. Now, we also talked in class that there is a little typo here. And that fact is that we would take all of the values of Tmax for every January, for every year. So we actually have to fix something here, and we can do that if I just highlight the text here and hit the parentheses. It'll put some parentheses around here. We'll add another condition, and the other condition we're going to say is that the year that we're dealing with must be equal to 2010, right? That's the only year where we want to calculate these mean temperatures. So for the Tmax values, we'll get the ones where the month is equal to month now and the year is equal to 2010. Once we take that section or that selection of temperatures out of the Tmax array, it should only be, for instance, the first time January of 2010 temperatures. We're going to take all those daily temperatures and calculate the average. So that'll give us a monthly value. And then we're going to increase the value of the index by 1 and go on to the next month. So basically each time we step through, we increase the index value by 1. If I run this, again, we did this in class, this should run, and if we do a print statement, we should see here mean average temperatures for every month of 2010 for this Detroit Willow Run weather station with temperatures in Fahrenheit. So these are the mean maximum temperatures, so the hottest temperature of each day on average is a little bit below freezing, for instance, in January, but by the summertime it's getting pretty hot. So just to kind of rehash, we didn't go through the list here, but to just remind you of what's going on, we made our empty array with 12 locations to store the monthly temperatures. We use this index value to go through and go from one month to the next to the next. If you start doing this for more than 1 year, it should become perhaps obvious why it's nice to just manually increase the value of index. So that's what's going on with that. We use the for loop to go through each month, and then for each month we then pulled out the values of the temperatures for just that month. And we added in here what's not in these instructions right now, but perhaps I can update on the course materials, is we added this condition that we also had to have the year be 2010. And once we did that, then we stored everything in means 2010 at location of the current value of index, and then increased index for the next time through the loop. So, it might take a little bit to kind of think through how that all works. It's not so bad, but it may take a little bit of just some time looking at the code and thinking like line by line what's going on. So our next task is we have these temperatures in Fahrenheit. Fine. Works okay for someone like me who has a sense of what temperature in Fahrenheit means, but temperature in Celsius is more familiar. So our job is going to be now to convert our temperatures for the means in 2010 to the equivalent temperatures in Celsius. And we're going to do that using a function that we've already seen before. So I'm just going to kind of quickly define a function. Here's our def statement. We'll call it far to Celsius, converting Fahrenheit to Celsius, and we'll just take a variable called temp as the parameter, the temperature that we want to convert. It's a simple function, so all we're going to do then is return temp minus 32. So we're going to do our conversion factor from Fahrenheit to Celsius divided by 1.8. And that should then allow us to convert temperatures in a single value or a NumPy array to their equivalents in Celsius pretty quickly. So if we run that cell, we'll now define the function. It's available to us now stored in memory. And that means that we could do something like this. We could do means 2010 Celsius equals our function name, far to Celsius, of means 2010. So the nice thing about working with these NumPy arrays is we can pass the whole array into a function, and it will calculate the values and return back a NumPy array. In this case, that would be stored as means 2010 Celsius. So that's handy. We don't have to go through value by value and calculate it or anything. We do the whole thing at once. And so if we print out the values now, means 2010 Celsius, what we see are values that look like this. So the average high temperature in January, before I mentioned it was a little bit below freezing. Yeah, here we go, -1. And it's hot in the summer. Yeah, there's 30 degrees. So summer temperatures in this area, average summer temperature in, I guess this would be January, February, March, April, May, June, July. Hottest month, 30.8 degrees for the average high temperature. So yeah, and this is a nice easy thing that's quick to do with NumPy arrays, and you're going to have that task for the exercise for this week, so maybe that's a good thing to know how to do. Now, we can move to a slightly different task here. And this is something you're going to, again, have to do for the exercise, and that is to calculate the average temperature in a given month for several years. So for instance, if we wanted to take the average temperature in the month of February between 2010 and 2015, we can do that. But it's a little bit different than what we did before. And before we did it for 1 year, now we want to take multiple years and average all of the months of February, for instance, to get an average temperature in February. And we're going to start out by making a mask. So month mask is going to be equal to month equals 0.2. So here's our condition that when the month is equal to February, that will be our month mask. We could do the same thing for years, because remember, we want to get years between 2010 and 2015. We can make a year mask. And year mask is going to be equal to, we have two conditions here. and you'll see why in just a second. So we're going to have to use parentheses since we have two conditions that we're combining. If we take our year and do as type int, we're going to convert from a character string to an integer. The reason for doing this is because then we can do something like, say, we want the year that's greater than or equal to 2010. We couldn't do that with a string variable. If you compare the number with the string, you won't get something reasonable back. But here, if we convert our year array to integers first, we can then say when the year is greater than 2010. That'll give us some list of true or false values in the array that correspond to the years that are greater than 2010. And we can use the ampersand to combine that with the second condition where we say year, again as type int, so converting it to an integer, and this time we're going to say it's less than or equal to 2015. So when we combine these two conditions, greater than or equal to 2010, less than or equal to 2015, we get a year mask that gives us only values between 2010 and 2015 as true. Everything else will be false, which means we'll be able to remove those values easily when we start selecting temperatures. So let's do just that. Let's make a variable here called mean 2010, 2015. Not maybe the best variable name of all time, but useful. And yeah, these are going to be values of Tmax now. Tmax clean for the range in our two conditions. So month mask and year mask. I could have typed this stuff in here as conditions when I was selecting things. I define these two masks separately just because it makes it a little bit easier to read that I've got a month mask, which is going to give me only the month where we have February, and they're going to combine that with the year mask for only the years between 2010 and 2015, and then we'll do .mean. A little bit of a long statement here, and maybe the logic is a little bit complicated to think through, but in the end, what we're doing is not too terribly complicated. We're just going to take the mean value of the Tmax temperatures that fit these conditions, month of February between 2010 and 2015. Month mask is not defined because I didn't run this cell. So I'll run the month mask and year mask cells, and then when I run this again now, I get something defined in mean 2010. Well, what did we get? Let's print that out. Mean 2010, 2015, 32.38 degrees. So close to freezing. 32 Fahrenheit is freezing, so February, that seems like a pretty reasonable value. If we wanted to, again, make it something that's more familiar, we could do print out far to Celsius of mean 2010, 2015. I haven't put February in the name of the variable, but it doesn't matter here. And you get that back as something pretty close to 0 degrees, 0.2, so plus 0.2, right around 0. That makes sense for February. Detroit area is a northerly latitude, and it's cold in the winter. Okay, so our last task in the lesson, the last thing you're going to have to do in the exercise this week, is to calculate something that we could call a temperature anomaly. The anomaly in this case is the difference between the average temperature and the temperature observed at some other time. So for example, we could take the average temperature for February in 2010 to 2015. February for those 6 years, find the average temperature for that period, and then we could look at, for instance, the temperature of February 2010 to see, like, was that hotter or colder than normal for that 6-year period. So we're going to do this in the exercise where we calculate an average temperature for a longer period of time. Could be something like 40 years, and say that, okay, let's look then at each year, how much does the temperature vary from the average value? how much does it deviate from the average value? And is there a trend in terms of how it's changing? Like, is it showing us it's getting warmer over time compared to the average, or something else? So let's do that. We'll calculate something called anomaly. And in this case, we're going to say our anomaly is equal to means of 2010. These are our temperatures observed for the month, or for the year 2010, monthly average temperatures. So the value in position 1 of this array would be the one that would correspond to February, second month. So we take the observed value of that year and take away from it the mean from 2010 to 2015. So we just subtract the average temperature from the observation for that month. That'll be our anomaly. And means 2010, not mean 2010. And if we print out anomaly, what we see is that the difference in temperature here in February of 2010 is pretty small. It's actually different than what I have in the lesson materials, and I'm not quite sure why that is. The point here is not necessarily whether or not this number is exactly right, but just to kind of show the process that we took the mean value for February 2010, subtract the average for the other time period where we've calculated the mean for February over 6 years, and then we're left seeing that 2010 February was just a slight bit warmer than average, 0.07 degrees Fahrenheit warmer than normal. And yeah, if I see why why I don't get the 1.7 degrees that I had previously, you know, if I see something, maybe I can add it as a note or a hint on the lecture materials. Anyway, I think that's it. So that's kind of what we had to cover for the lesson, and I will stop here, and maybe I'll come back and just do a quick preview of the exercise to walk you through that.